So I'm Stephen, I'm a CTO, co-founder of Dataloop. Started the business about 3 years ago now. For those that saw the talk before, you'll see the long journey into suffrage of getting into monitoring as a service. And I want to tell the story about Dataloop, how we built Dataloop, how we monitor our own software with our own software, some of the issues we've had along the way, and then focus more on sort of the developer analytics. So in the room, who's a developer and who's sort of more operations? So developers? Oh, cool. Okay, you'll enjoy it. Operations people? Oh, good. Okay. So Dataloop. The idea was that we would combine operational type monitoring and developer monitoring all in one, so that you'd have like a replacement for Nojs that would do your up and down checking. It would take your performance data from scripts, literally Nojs check scripts, but you could also fire in development data, so Graphite, StatsD, and now Prometheus data, and you get it all into one place. Do lots of cool stuff with dashboards, set up your alert rules, but we wanted to go one step further and actually pass it down to the individual teams. So I've been in central teams before. You need a bit of control and oversight, but it's much nicer if you can give a tool to somebody else and they run it. Then you don't have to do the work. So the plan was with Dataloop to make it very much self-service and SaaS as well, so that you didn't have to run it yourself. So I've got better at diagrams since this. This is like the first architecture diagram 2.5 years ago. When we first sold Dataloop, it didn't really exist. It was just on a laptop somewhere. It was enough to demo anyway, and we connected up to cloud. It was on Heroku eventually, and we were connecting up to some SaaS server. And we told the people that bought it that this was what we were doing, this was the plan, and then they sort of financed it and through consultancy mostly, and we kind of built it over the period of a year. We thought we'd over-engineered it. You know, we thought we've only got really one customer. You know, we're looking to get some more, but we need to build it and make sure it works and get some feedback. We could probably have done it just as a big monolith on a laptop and just got it working. But we thought ultimately, like, as a SaaS service, you probably don't want to have lots of little monoliths, and you don't really want to go through this whole, let's split them out at the end. So we thought we'd start it from the beginning. I know some people say that you start off with microservices, you're doing it wrong. It's a kind of a balance, I think. This actually did cause us a lot of pain. We might have been better off doing it more monolithic. It's not me. Okay, cool. So it's a pretty simple architecture, to be honest. You've got RabbitMQ. We like Rabbit. It's quite cool. You scale it quite well. You can scale any of these things. Just put more of them in and distributed hash them, just to shard across. But lots of sort of Node.js services connected up to Rabbit. We were using React initially for our Timeseries database. We took a bit of a trade-off that something in the entire stack had to be stable, and that and that probably the data was the good thing to keep stable. So we foregone on the features, because React's just kind of like a key value store. So we started off literally just building something that would replace Nojs and scale, take time series data, but not really do analytics. Like, we'd come back to that at the end. And then we'd split up things depending on what they're doing. So we made like a little telephone exchange where all the agents could connect into. And we have this bidirectional WebSocket so that they can run on boxes. You can push scripts down to them. That's the self-service bit, so that you can create things in the browser, push it down, and then they can send back metrics. But we would also collect up and have like an entry point for people to push third-party metrics in from Graphite, and obviously process them and all that sort of stream processing type stuff. And then obviously getting it back out to the browser so you can do it in dashboards and alerts. So for the first year we were going, all right, well, I was a bit worried about this stage because we weren't really selling much. But then we got 2 customers literally on the same day, and they were massive. We got like 5,000 or 6,000 agents all landed at once, which was really cool, but that's what really happened. Like, even though we'd built the Ark and I thought it was impenetrable, the rain came and it sunk. Massive. Nobody noticed, luckily. We did lots of things behind the scenes to stop it. But yeah, that really hurt. We stopped onboarding customers at that point. We thought, let's just fix what we've got. And the first thing that we did, like whenever you're in a big panic state, you think, oh, I should probably investigate what's going on. We had a fair bit of monitoring data already, but we were mostly monitoring sort of our Node.js processes. You know, the traditional ops stuff. Are they up and down? What's the memory like? Most of our stuff's on queues, so we're monitoring lots of queues. We've got hundreds of queues, and we thought we could probably live just by working out the number of messages on the queue and the rate, and that would tell us an indication of what was going on with the app. Yeah, that didn't work very well. So we did what every person does in this situation. We threw Redis in the middle. It's a common scenario. You have a problem with scaling. You just stick a massive in-memory cache in and ignore that it's a single point of failure. So we stuck that in. That buys you a few million requests a second, and then you can work around the outside to keep things going. So that was kind of the first bit. So we still had the bit that caught fire was we were able to ingest the metrics, put them onto the queue, but we were doing stuff in order to write them to React. You'd have to take them off the queue in a distributed way, and you'd have to try to merge the points together in cache on the boxes and then write them in batches to React, because React wouldn't let you just fire millions in. It didn't have enough performance. So yeah, we had those problems. So the other thing was, and we've retrospectively agreed that Node.js is the prototype language. I mean, at the time, it was the real language. But no, we've agreed that we did it for speed of development, and that we'd chosen this language, which was supposed to be the be-all and end-all. You could write things in the browser, you could write the server-side code, and you could learn and become a master of the language. Yeah, we're using it for the bits it's good at now. The thing with Node.js is you get to about 1.5 gigs of memory, and then it just falls over. Like, it will start garbage collecting around about 1 gigabyte of memory. So what you then end up doing is, obviously they're only sort of single-threaded. If you've got 8 cores in a box, you run 8 Node.js processes. None of them talk to each other, so they all talk over the queue to each other on the same box, which is okay. It's kind of working, but yeah, you've got to keep an eye on them. And it's not great when you're trying to take a load of metrics off of a queue, put it into memory, and use some of that memory as a sort of a temporary cache for rolling them all up together. You end up trying to manage in a 32 gig box, 8 gigs of memory across 8 processes. It's a bit of a waste, and then they're all dying all the time in garbage collection. Bit rubbish. So yeah, it's kind of like an infinite YOLO loop. They go round and round in this event thing, and who knows where it stops. So yeah, we needed the big caches. Garbage collection times were just killing us. So we decided that we were going to take some of these microservices and we were just going to rewrite them. So we did what any startup would do. We picked a massively esoteric language we couldn't hire for. Which has worked out well, actually, because we've been able to sort of attract some people that wouldn't normally work for a company unless we'd have picked that language. So I think one of the guys from Y Combinator wrote about it. If you pick one of the newer languages, you're able to attack some talent that possibly wouldn't have considered you before. So we had a few, I hate to say the word autistic, but they liked Erlang. Like when we put it in front of them, it looked to me like a stack trace, but they seemed to like it. And within 6 weeks, they'd taken that particular process, rewritten it in Erlang. We weren't getting crashes anymore. Or we kind of were, but Erlang likes that. It's kind of let it fail, and it will carry on. And then you can fix it live. So yeah, we reduced the servers down. I think whenever you rewrite stuff, you end up reducing servers anyway. But I just thought I'd put it up there. And obviously, we took out that Redis layer. So the Erlang stuff was pretty good. We could use all the memory in the box. We could have one single sort of beam VM that would suck all the metrics in, manage the metrics efficiently, and then push them straight into. We decided at this point we'd get rid of the stable bit. That we would invest in our new database, which is also written in Erlang. We switched over to Dalmatina DB at the same time. So we wanted to get the analytics features in. We thought if we stayed on React for much longer, we'd have to build those on top, and it'd always be slow. So while we took this kind of experiment, we took both ends of it. One was we would make the workers more efficient, and the other one was that we would just go for a magnitude leap in performance on the database, which is why we invested there as well. So I got better at diagrams at this stage. I found a new tool for doing them. And it's pretty much still a similar architecture, except this time we've got Rabbit, still got the things coming in, still the collectors. We've got our new Timeseries database coming in. We added extra services, for single sign-on and multi-tenancy and things, but that's pretty much it. So a happy ending, right? That's not quite. It's kind of just the beginning, because as doing all of this, we realised just how kind of blind we were to most of the problems, and that it was cool that we'd survived We're able to sort of onboard a couple of large customers, get it working just by throwing different technologies in, replacing the few bits that we knew that were core that we needed to replace, and got that working through some consultancy money at Erlang Solutions to get us there quickly. And yeah, we were pretty much there. But what we wanted to really do was start to look more into the code. We're a monitoring company. We already had some statsd stuff in the code, except when you're trying to work out the number of metrics per second that you're scaling through the workers, and you're emitting a UDP packet every time you get a metric through. Some of the boxes were sending like 20 megabytes of UDP traffic per second, and we were getting blocked by our ISP for DDoSing various bits and pieces. And I was going in there every day commenting out bits of statsd code just to get it working, which was annoying. It is good though, you get lots of visibility, it's just it wasn't great for our use case where you've got high throughput. So we still support it. We've still got, the great thing about microservices is things live forever because you can't bother to go back to fix them. So we've still got bits of statsd in different services around that we haven't moved over. But I don't know if you guys have seen statsd. I'm probably overstepped the bit, but statsd is a library that you can, it's an open source one from Etsy. You can put it into your code. You can decorate your code with counters, gauges, statsd gives you sets and timers. And then every time in production that piece of code is hit, it will emit a UDP packet. And that's something that we can then graph and alert on. Which is cool, and it's quite easy to use. You can see here's some sort of sample Python code. Just use a decorator. You've now got a timing for that particular function. Kind of like APM, but it's more custom. I mean, you can use this for loads of different things. Whatever metric you want, you can graph. So we, just been through the bad things. As your throughput of the service increases, the number of metrics emitted from statsd increases. UDP is not great. Like we'd have issues, and sometimes they were network related, and you just lose all the UDP packets. The other annoying bits about statsd is you're taking normally all these metrics into a central point, and then you're performing calculations on them. So if it's a timer, you'll get like percentiles, or if it's a counter, you'll get like a rate. Automatically calculated, but you lose all this data, it'll just aggregate it all. So you can't then get back to the individual node, you'll just get the service level, which is okay for an indication, but if you've got a proper problem, developers are quite happy just to see, how is my service running as an aggregate, but when you're in, you want to actually work out which box it is, because normally it's one of them's gone a bit wonky, you want to actually know which one it is, so it not only does it you lose that specific host, but it's kind of lossy. So we switched over actually for all our endpoints. We moved them all over to Prometheus. It's a slightly better design. Who's heard of Prometheus? Yeah, good. Yeah, it's a better way for doing this stuff. It's fairly new. Came out of SoundCloud a couple of years ago, but it takes it the other way. Instead of it pushing all the packets out, all you do is in your app you just expose an endpoint, and then you expose the raw data, so you don't lose any. You just literally within your app instrument it, so you can. There's another Python example. Add the Prometheus Python client. It will start up on port 8000. Somebody wrote on Twitter, why would I add an HTTP endpoint to every single service just to get metrics? Well, it's easy. It's a lot easier than troubleshooting 30 megabytes per second of UDP traffic. And they're pretty easy. Again, you can just decorate with timers and stuff. But the cool bit is, obviously, you can then choose how often you scrape. So a lot of these metrics are just counts. So if you decide to put this in, it's really lightweight in the background, it's just going to keep counting up. If you decide that actually you just want to collect that every minute, well, you're just going to collect a counter every minute. It's pretty easy. I mean, we have our set to 10 seconds. You can go down to 1 if you want to. So, but yeah, you collect all the raw data, and this is where the analytic stuff comes in. So in the older tools, you'd want to submit metrics, you'd have a service calculate stuff up for you, and then you'd present it. In the new world, you can actually send all the raw data in, and then you can always use that to go back to answer the questions. So if you want to calculate the rate of something over time, or you want to divide that by something else in future, or get to a completely different number, you've always got the raw data to go back to. So by collecting all this stuff, there's nothing that, oh, I wish I hadn't aggregated along that dimension. You've got it all, doesn't matter. And also with the tags, which is StatsD is a fairly flat data model, which means that you encode your namespace in dot-separated paths. Dimensions are much cooler. You can just arbitrarily put dimensions on stuff. And then you can actually at that point drill down into the individual host as well, which is a lot nicer. So overall, this is just far easier to use. And again, if you're running StatsD nowadays and you don't want to buy Dataloop, then set up Prometheus. It's pretty cool for dev monitoring. And this is the output that it gives you. I mean, if you literally curl localhost on whatever port it's on /metrics, it will give you this type of output. They don't actually use this in the spec. This is one of those great ideas that they put in. That I've done that a lot, in designs. But all of this stuff is used. So you've got the thing that you're monitoring. You've got the value you've got the dimension and then the actual value. And because you're scraping, you don't need to include a timestamp. The timestamp is the point at which you scraped. So it's pretty simple. So what would you instrument? Everything. It's pretty lightweight, isn't it? Why not? It's pretty cool for instrumenting features. So if you're ever having sort of a talk with a product owner and they're saying, oh, we must embellish this feature, you can turn around and go, well, actually, nobody's ever used that in the whole life of the product. Here's a graph showing 0, which is quite nice. Throughput is really good for that. So now you can actually, you can start to, you don't have to go in and start commenting out lines because you're generating too much traffic. Who cares if that counter goes up really quickly? It's just a number. You get 64 bits worth. And obviously error rates, throughput, that sort of stuff. We've got a lot of that stuff now. We've put it into our newer services. We need to go back and put it into our older ones. But yeah, that's pretty cool. So now you've got all that data coming in. There's some of the stuff that we're collecting, which actually is quite easy to do. You can start collecting response times for all your APIs. So with Dataloop, you can connect Grafana up to it. You can do the same with Prometheus as well. You can start just scraping all these response times out of your apps. You can then start to work out which are your slowest APIs. This was me. It's always me. I've always done something. I think I accidentally left a job on that created events in a loop. And so when we didn't have like a limit on the API test to 100, and so it just kept building up over time as my events started being created. But my monitoring caught it as well, so which is quite cool. You can also do this sort of cool analytics stuff where you ask a question. Well, it's pretty high CPU, but what was it like yesterday? Or this thing was doing this. It's making a weird shape, but has it always done that? And the older tools, it's quite difficult. You end up having one browser, another browser, and then you try and sort of line them up. So yeah, it's a bit terrible. This stuff you can actually you can start using SQL style queries in it. You can get all your data in. Say like from my production account where my tag is the application servers, give me the CPU, average it out over the interval, call that one current, and then do the same thing again, but time shift it by 24 hours and call that one yesterday. So you can do loads of cool stuff with this once you get all the data in. And again, yeah, it's just a SQL style language. That Grafana thing's just literally generating a SQL query behind the scenes that you can send off. We've added group by more recently, so you can start to, let's say you wanted to get all of your containers across all your Docker hosts, but group them up by the Docker image ID, and then work out from that the CPU usage, and then take a derivative, and you can do loads of crazy cool stuff. You can't see any of these, can you? No, it didn't come out too well. But you trust me, they're functions. And Timeseries is a unique thing. In SQL, you'll get some functions, but Timeseries, you get a lot baked into these Timeseries databases. I mean, we work on Dalmatina-DB, but if you're familiar with InfluxDB, or Prometheus has them, OpenTSDB, they've all got these time series related functions that are specific to that sort of data. So you can easily calculate rates, that sort of stuff. You can even go on so far as, so for Prometheus, for instance, you can do a linear regression over your data and start to plot into the future when your disk is going to run out, that sort of stuff, which is quite cool. I think some of the ones have got, I saw a Solar-based one, Lucene-based time series database where you could search for metrics that looked similar, which I thought was quite cool. Maybe in a problem situation, you're probably pretty screwed by that point, and you want to hit the "I'm feeling lucky" button. and then and it will just go, oh yeah, here's things equally weird to this. I've been in a few of those where you just think, ah. So yeah, we're going to be adding a few new functions. I mean, Dalmatine is completely free. We used it to solve our problem. Not many people have our problems. Not many people are starting up a SaaS company that need high throughput databases. But if you do, we contribute it all back for free. You can install Dalmatine DB on premise on your stuff. It's just a few components. It's not massively onerous like a Hadoop cluster. It's got an Erlang backend package that you can install. You can install the front end, a proxy. The proxy actually takes in any metric type. You can send in Graphite, Prometheus, FluxDB, just fire it all in. And you can still scale it out by just, like React, just adding nodes. In fact, Dalmatine is based upon React Core, so it's got the sort of that library, the lower level one inside it. So yeah, we'll be adding that stuff. Talked about the similar, I really want that similar metric one. Outlier algorithms as well. It'd be cool if you could plot a line above your graph for alerting purposes, so that you could sort of have one query without the function, one query with the function, and then if you divided it -1 from the other and it was less than 1, you would then get an alert, because that would give you your outlier detection, so you could see what was going wrong. And there was obviously loads more functions. So quite a short talk, but hopefully I was going to do a rerun of the other one, but I thought I'd do this one. Code level metrics, they're much cooler if you use Prometheus. Yeah, you should probably have a framework in place to get those metrics into your code really quickly. I mean, we were really busy firefighting, adding components to solve the scalability, and we also needed metrics at the same time, and it would have been just easier to have had this in place first. Obviously, don't wait for things to go wrong to add metrics. And I mean, you've probably seen, you need to get your Nojs stuff working, obviously, but you need your developer metrics in there as well. Health checks are good, but actually instrument all of your code and get them in the same place ideally, so that you can start seeing it together.